Yesterday I showed you a ship, yeah, before we all left off, and I gave you with a thought that which side would you like to bring this vessel alongside, port side or starboard side. So we're going to see a short brief video about use of tug, small thought about pivot point. Now, pivot point is basically the axis along which a vessel is going to turn. The moments are going to be applied. So if this axis, the pivot point is here, and you apply a force in this direction, well, the vessel is then going to be turning around this axis. Yeah? So it is quite important for you to know where the pivot point of the ship lies. Now, basic general thumb rule is when a vessel is moving ahead, yeah, the pivot point is 1/4 of the ship's length from forward. And when the vessel is moving astern, yeah, when the vessel is going astern, the pivot point shifts same 1/4 of the ship's length from stern here. And when a vessel is stopped, the pivot point is somewhere around the center of gravity of the ship, somewhere around there. So if the vessel is stopped and you turn here, you take it up. If the vessel is moving and you apply force here, make sense? Basic idea.
This idea applies for all kinds of vessels?
Yes, general conventional vessel, yes. Now, there is an exception to this. Is, for example, if a ship starts going very fast, yeah, too fast, small craft, small vessels. This one starts going forward. If a ship is stopped and when it starts moving, as it gains speed, pivot point will start moving forward. Okay? Some boats, like the speed boat that you see, they are going really quick over the water. Their pivot point is outside the ship. That is why when they will turn, you see the flip if they apply too much rudder, because the force is too much. This is basically a lever, turning lever. So if your pivot point comes over here and you apply a force over here, this is all your lever. When it's too much, you have to apply very gentle force. You can relate it to the amount of force that you need to turn. So if your pivot point is sitting over here and you want to turn your vessel, if you apply here, you are going to apply a lot of force, a very big force you have to apply, because this lever is very small. When the pivot point is here, and if you end up applying such a big lever, the result is going to be way more, because you have a big lever here as well. Yeah? Yes. Okay. So this is, I will load the exercise here.
By the way, we couldn't open the volume of the thing before. How
I'll try.
How is it working? Let's see. Give me a moment. Would they provide us with two screen or one screen? No, one screen. You need the stable second one. Don't worry about it. In the meantime, you'll find it. Just you should be alert all the time. Whenever see an unattended screen, you'll take it out. Okay. Or you can buy one. It's like it's not that it's 25 pounds. 25 pounds? The second hand, right? It's not around. Okay. From creative you don't need to buy it. Also like second screen something and make a difference. Like just make it bigger. Yeah. You probably can make it like three of them. You can connect three of them. You can put want to do. They don't want to use 316 and but
I've seen Chinese guys using this.
yeah,
like for reading.
So in the meantime, this is your ship. Yes. This is the bulb. Yeah. Wind is blowing from 090 easterly wind.
Okay.
So, like you said yesterday, I said which side are you going to bring this video? Bring the ship alongside.
Why they make like confuse people? Wind coming to people. Why is that?
Difference between this and reading. So they can read people. People are educated.
But it's opposite for current and the wind. If you say night wind, it's the same.
For example, if you are measuring the wind coming this direction, you can go from there. Not telling that way.
Look, now it makes sense.
So this is the fourth thing. Or opinion,
So first we will watch a short video that you learn the concepts about working with tugs, what are the different kind of tugs, then we will show you how are you going to use the tug, which side you should use tug, what tug. So let's watch the first video. You said the volume is not working, it is very lossless.
we put it on the stove.
Oh, it's not working.
So why are you choosing the one two?
For coding, program coding. It's easy to see the like whole perspective.
Well, I may need one. Or maybe I bring the Chinese back to the playground. I give ideas to programming and
Yeah, they're really good programming. They can just, what was the basis was roses are blue. No, right, sorry. The sky is blue, roses are opposite. Roses are red, sky is blue. There is always Chinese guys rather than you or something like that. The point is you got the point.
yeah. We got it. Yes, that's true. I don't know why. So better than us anyway.
They, because of their, I think, discipline they got, like they can work very focused without like any break, etc. Even, if you realize they sleep on their desk, but not like they, for example, when they try to like sleep on their desk for a focus for that, they just let one of them continue working till if they can work till midnight, 2 a.m., 3 a.m. But when they feel tired, they suddenly sleep on their desk. It doesn't matter when working time.
Well, actually, we are not feeling tired, but we work a lot. Then it is, I work a lot. I need to take a break.
In today's shipping market, the size of vessels is increasing faster than ports can grow to accommodate them. Harbour operations are becoming more complex. Time pressures and increasing traffic are making ever greater demands on tugs. To meet the challenge, tug crews depend on the professionalism of vessel crews. Good teamwork between everyone involved is essential. But teamwork a shared understanding of towing techniques, tug capabilities, and the ship's requirements. It requires effective communication between the pilot, tugmaster, bridge team, and deck crew. It also depends on both crews fully understanding what is going to happen and when. Where and when will the operation begin? When will it finish? What manoeuvres will take place? For harbour operations, it is essential that standard plans and procedures are agreed in advance by pilots, tugmasters, and port authorities. Relevant procedures should be relayed to each vessel's master before arrival. These will provide the foundation for individual plans for each operation. There are many elements to consider. Where best to pick up a tow? Off fairway buoy or nearer the berth? Where is the vessel berthing, and what is the best approach, taking wind and tide into consideration? How many tugs are required, and what type of support is expected? A tug on the bow is normally used to assist manoeuvring at low speed. Alongside or hip tows are used when extra manoeuvrability is required in restricted waters. Escort towage can assist steering and braking from the stern. Combinations of these techniques are often employed. Sometimes all that is required is passive escort, where the tug is standing close by for support if needed. It is important that the pilot is aware of the safe working load for the vessel's bits and fairleads, and is able to relate these to the power of each tug and its line. Different tug types have different qualities and different strengths. Today, stern-driven tugs are either conventional or azimuth stern drive, or ASD. ASDs can tow over the stern in the conventional mode, or over the bow in tractor mode. For ship handling, an ASD will tow over the bow, in effect working as a tractor tug. Tractor tugs with propulsion at the front are very agile. There are two major designs: Schneider and azimuth tractor. Recently, a new breed of highly maneuverable mini-tug harbour operations has entered service. Each type offers a different balance of power and maneuverability. Each has different capabilities and different limitations. Their suitability for various tasks should be assessed by pilots and tugmasters.
The interesting thing there is the ratio between the head and stern behind
and included in the standard operational plan. In briefing the master of a vessel, the pilot should explain these operational plans.
Once we get off the berth, we can let go for a tug and push.
Fully completed standard pilot cards should be presented. During the master-pilot exchange of information, the vessel's master should provide the pilot with key information, such as the safe working load for the vessel's bits and leads.
And the safe working load of bits, 50 tons.
Their position, and the minimum steerage speed for the vessel. From these exchanges, the best making fast position and approach by any tug should be agreed. and casting off a tow line. The minimum speed for picking up a line. The maximum safe speed possible with tug made fast. On the approach, where best to secure so that steady course and speed can be maintained.
Second, we have phase radio on 12.
The working channels for radio communication.
Cable.
The forces involved in towage operations are considerable. The weight of equipment to be manhandled. The power of winches, capstans, and engines. And the forces of wind, wave, and tide. There is the vast difference in power, size, and maneuverability of the vessels involved. Taken together, these can create a volatile and hazardous environment in which mistakes can have serious consequences. The risk assessment must be methodical and reflect the operational plan. Each phase should be considered and evaluated. This takes time.
Yeah, that happens. It's fucked out for insurance. That's fine. Yep.
What risks are there in each maneuver? What hazards will be presented by the equipment used? Where would equipment failure present the greatest danger? Who is most at risk on both vessels? What will happen if communications fail? Will other vessels' movements create a hazard? And where? What effect will wind and tide have? Is visibility likely to deteriorate during the operation? Have the hazard from the vessel's cargo been taken into consideration? What contingency plans are there? If there is a problem, what action will be taken? Do the pilot and tugmaster agree?
Yeah, okay, Gareth, thanks a lot.
Accidents have a habit of growing from a series of failures. For tugs, arriving on time is essential. It avoids risks occurring from hasty assessments and late control. It is also good practice to allow extra time for unforeseen difficulties.
Sorry, wait on starboard.
With communications, people, or equipment. All equipment must be regularly inspected and maintained. A worn tow rope or a bad lead may cause a line to park, and control of the vessel may not be recovered before an accident occurs. When a line parts, there is extreme danger for anyone nearby. An engine failure when towing may cause the tug to be overrun by the towed vessel. It is essential for the tug winch release to function under load. It should be tested before every towage operation. The tug master should assess the pilot's instructions and query any that seem unclear or inappropriate.
And repeat the warning, please.
When you're ready, push on, gear power.
the operation, however routine or obvious it may seem. It is equally important that the vessel's deck crew is briefed on the plan and what is required of them at each stage. Where are lines required? To what should they be made fast? And when? For the deck crews to perform their task effectively, equipment must work faultlessly. Inspection and maintenance is essential. Roller pins on fair leads may wear and fracture if not regularly greased and inspected. A damaged fair lead can destroy a costly rope or cause a personal injury. Bits and chocks are subjected to heavy loads during towage. They should be inspected regularly to ensure they are in good condition. Ropes and wires can also fail if not maintained. Wires should be checked for corrosion, kinks, and oiled or greased regularly. Ropes should be checked for chafing and splices for security. It is common for there to be confusion about which bits are designed for low-stress tasks such as mooring, securing barges alongside, and which are designed for towage. It has been known for incorrectly used bits to be ripped right out of the deck. Masters should know the safe working loads of the bits on their vessels and provide this information to the pilot.
Now, what's the safe working? Bits are, and what are the interpreted art is to work.
Winches on vessels should never be used to make fast towing lines. They should always be made fast to bits designed for towage operations. Deck crews should be aware of the tug's equipment. It has been known for crews to mistake a tug's messenger line for the tow line and make fast with this. When this happens, the tug cannot apply load and control of the vessel may be lost through the delay. Lighter messenger lines can also be deceptive. The vessel's deck crew may start hauling the messenger line by hand, but then struggle when the heavier tow line hits the water. By then, it is too late to employ a winch. Delays occur while more hands are summoned to help. Having sufficient crew to pick up lines and make fast avoids delays and reduces risk. With a properly briefed crew, mistakes such as incorrect bit selection or making fast with a messenger can be avoided. Existing SOLAS regulations require emergency towing equipment on tankers of 20,000 tons deadweight or more. New SOLAS regulations require that emergency towing procedures are provided on all passenger ships by the year 2010 and all existing cargo ships by 2012.
I say like ultra cardio.
Specific challenges. With heavy traffic and limited manoeuvring space, vigilance must be maintained. It is important to remember that most harbour towage operations are conducted under contract, which impose liability on the owner of the vessel for loss and damage that occurs. Even if this arises as a result of the fault of the tug. This imbalance makes it particularly important on board those ships do everything within their power to ensure that the towage proceeds without. Planning should include an assessment of the worst case situation, and action should be taken by all vessels. The aim should be the safety of personnel, tugs, and the ship, well as damage limitation. Before the operation begins, the master must be satisfied that the tug is adequate for the task. During the operation, it is crucial that both tugmaster and the vessel pilot understand the constraints under which the other is operating. For instance, many vessels have a minimum speed at which steering control can be maintained. Does the pilot understand the power of the tug? This is important if he is to ask for full power. From the bridge of a large vessel, the tug will frequently be hidden from sight. The tug master should keep the pilot informed about his movements. When casting off, as the line is slackened, the swell will often drop the tug and tighten the line. This can be dangerous for the deck crew on the larger vessel handling the tug. It is essential for the tug master to remain vigilant and release the load quickly. Injuries must be avoided. Deck crews must keep well clear of tow lines as weight is put on. There are often other tasks, such as preparing mooring lines, to be accomplished nearby. The danger here is that concentrating on their other tasks, deck crews may fail to see the line moving towards them until too late. Loss of a leg is a heavy price to pay for a moment's carelessness. The tug is always vulnerable to being damaged or overrun by the larger vessel. One of the greatest moments of danger for the tug is when picking up a tow line from the bow. The vessel's overhang can make it difficult for the tug to close. At speed, the tug's steerage can be affected by large bow waves. Hydrodynamic forces can push the tug away and then suddenly suck it into the bow. At this point, it is possible for the tug to be overrun. By operating at a safe speed, interaction can be reduced. All in all, this is a vulnerable position that needs to be cleared as quickly as possible. Bulbous bows can be dangerous to tugs, especially when the vessel is laden and the bulb underwater, or when operating at night. The vessel master must make the pilot aware of any underwater obstacle, and warning should be clearly marked on the vessel's hull. Bow thrusters can also be hazardous. Warning must be given before they are used. When making fast at the vessel's bows, a heaving line should be used that is long enough and light enough to allow the tug to stand off a little. When the line is acquired by the vessel, deck may be out of sight of the tug. The tug's crew need to know when the line has been made fast, as it cannot leave its station until this is confirmed. It is not unusual for a vessel's deck crew to walk away without informing the tug that the line is made fast. This leaves the tug stuck in a potentially dangerous position, unable to move for fear of injuring the vessel's crew. When casting off at the stern, it may be tempting to drop the line onto the tug's deck below. But with freeboards of 6 meters or more, heavy tow rope will acquire enough energy to seriously injure the tug crew below. It may also foul the tug's propulsion system, released before the tug is ready to take the line. It is important that the towing line is lowered carefully, and that any messenger line is not released till the tug is in a position to retrieve it. Many injuries have been caused by throwing weighted heaving lines onto a tug's deck. Heaving lines should contain no additional weight within the monkey's fist. Stern pumps in the escort role can suffer from loss of power as the wash from the vessel can disrupt the propulsion system on the tug. It is essential the vessel increases power only when the tug is ready and in the escort position. Equally, when a pilot or master goes astern or ahead without warning, the tug can be pulled towards the vessel. Any significant change in engine speed, direction, or rudder angle must be notified in advance and acknowledged by the tug master. Clearly, successful operations depend on effective communications between all parties, tugs, bridge teams, and ship deck fore and aft. Each speaker must identify themselves and keep transmission short and to the point. Most pilots have a portable radio, and this should be tested before operation. Interpretation leads to an act. The pilot's orders should have only one interpretation and be addressed to the same tug master should knowledge these and identify these the difficulty is direct and those on the tug makes it inevitable hand signals will be given by both. Standard signals exist to ensure the common understanding. All crews should know them and use them. Stop, danger. Emergency stop. Take the straight or hoist slowly. Raise, heave away. Lower. Secure, make fast, or it is made fast. When operating offshore, the longer timescales make planning and risk assessment more important still. There is more time for weather to change, more time for equipment to fail, and assistance is further away if required. What is the condition of the vessel or rig to be towed? Is it light or is it loaded? What are its draft and air draft? How will wind and current affect the vessel? What tides and currents will prevail during and after the estimated time of arrival? How much fuel is required? Should weather deteriorate seriously, are there any ports of refuge en route? If the destination is a port, what tides are involved and what berthing drafts are available? Voyage planning should be berth to berth. Larger vessels are likely to require the use of more than one tug. This increases the need for careful planning and good communications. Offshore operations entail all the risks associated with harbour operations, but with some crucial additions. The weather is a major consideration. How long will the tow take in fair weather, and how long could it take in poor conditions? Significantly more power is required to tow a vessel in heavy sea. If weather deteriorates, how much extra sea traffic is likely to be encountered? What are the conditions at the reception port? Offshore, tow lines tend to be longer, allowing for greater catenary effect and safeguarding bits and lines. However, wear and tear on lines is greater. Chafing is a constant threat, and it is advisable to change the length of line slightly at frequent intervals so that wear at the lead or rail is minimized. It is essential that all equipment, lines, winches, bollards, and bits are in good order before setting out.
Wow.
Re-rigging a tow in heavy weather is a difficult and dangerous task. Emergency tow lines must be available on the towed vessel. In a swell, lines are normally lengthened to give greater catenary effect and avoid shock loads on both the tugs and the towed vessel's equipment. The greater distance between tug and tow is a hazard for other shipping. In low visibility, it may not be obvious that the tug and tow are linked, and vessels may try to pass between them. Correct navigation lights and day signals must be used at all times to avoid this risk. Busy sea lanes are particularly hazardous, especially near harbour entrances where crossing traffic is encountered. In congested waters, navigational warnings should be broadcast. Careful lookout using all available means will go a long way to mitigating these risks by ensuring that the tugmaster has a comprehensive picture of traffic around the tug. Whether undertaking harbour or offshore operations, common good practice will help masters and pilots get the best from the tug. Equally, there is much the tugmaster can do to reduce risks both to his vessel and crew, while ensuring that his customer remains satisfied with service. Understand the constraints under which other vessels are operating. Change information about the minimum steering speed, the best speed for making fast, reach load, and bollard design strength. For harbour operations, standard operating procedures should exist and be updated regularly. For offshore operations, a plan should be created before commencing the tow. Reflect on the risks, both for towage and berthing, and assess ways of reducing them. Then define and agree the best risk management strategy in each case. Ensure communications are sufficient to achieve good cooperation between the bridges and deck crews of
We'll watch
both
another
vessels.
short video, yeah, for the use of tugs.
In harbours and ports where manoeuvring areas are confined and shallow, there are many navigational restrictions. Therefore, ship operators are required to manoeuvre their vessels in accordance with the environmental situation. Additionally, when the entering and leaving of ports also involve berthing and unberthing operations, ship handling without assistance is not easy. This difficulty is due to the problem of directional control and course keeping, a direct result of poor steerability at low speed and the influence of wind and current. Under such circumstances, ship operators are required to use assistance in ship handling, assistance such as the use of tugs when necessary, in conjunction conjunction with their own full understanding of the maneuverability of ships, including the ability of rudder deflections to check yaw at low speed, and the stopping power of various stages of reverse engine revolution. In addition to a ship's main engine, rudder and thruster, tugs are used for ship handling assistance in bays and harbours. Tugs are classified by propulsion type as follows: Voigt-Schneider propeller, VSP type, controllable pitch propeller, CPP type, and azimuthing drive propeller, Z type. In Japan, the azimuthing drive propeller type is the predominant type. Such tugs are equipped with two steerable propulsion units that revolve 360 degrees. By controlling both the direction and revolutions of the propellers, tug assistance for ship handling is available in all directions and with varying thrusts. The use of tugs is decided in accordance with ship handling requests, such as control of towed ship's speed, lateral motion, and yaw rate. In pulling out operations, the tug's paid-out rope length is reckoned ranging from double to 2.5 times the tug's length, L. As the towed ship's size increases, still longer rope is used. This is the arrangement for assistance in lateral motion control by one tug. It is common to use this arrangement in combination with a bow thruster or with an anchor. This is the arrangement for assistance in lateral motion control by two tugs. This is the arrangement for assistance in pivoting motion control. In the tug operations, either the pushing or pulling method is used. The pulling method is needed for broad sea room. This method has the demerit of towing force decrease due to the impact of discharge current, but it has the merit of a flexible use of tugs. When a tug tows the stern of a ship, the ship's pivot point will be aft of the bow, about 1/3 of the total length of the ship. When the bow is towed, the pivot point will be forward of the stern, about 1/3 of the ship's length. As the point of action C exerted by the tug moves closer to the ship's centre of gravity G, the pivot point P moves farther from the centre of gravity G. Consequently, turning in a short round requires a circular manoeuvring area with a radius greater than GP plus half of L, with the turning centre at the pivot point P. That is, the farther the point of action from the centre of gravity, the smaller the turning radius. A ship under 1 knot headway then makes a 90-degree turn with the assistance of a tug pushing either the bow or the stern of the ship. It is known that pushing abeam the stern of a ship causes a relatively large kick-out. At the same time, however, it enables the ship to turn in a smaller manoeuvring area than if the ship were pushed abeam the bow. When a tug assists the pivoting motions of a ship under strong wind and current conditions, the operation of towing the bow in the direction of the wind and current requires a broad manoeuvring area due to the ship's increased range of motion. On the other hand, the operation of towing the stern against the wind and current is effective for pivoting in a small area. The ship will be in motion close to turning in a short round. Therefore, close attention should be paid to ship handling in manoeuvring areas with strong currents. handling of berthing ships, it is very important to control the ship's approach velocity as well as directional control. As a ship approaches its objective location, its headway should gradually be reduced and the hull inertia should be stopped at the predetermined point. On the assumption that the ship can employ braking power through the use of dead slow astern engine, guidelines for speed reduction schemes for LNG carriers, PCCs and container ships are shown in this graph. This is a guideline for a speed reduction scheme for VLCCs. To prevent damage to the wharf and fenders, a large-sized ship should reduce its headway to zero somewhere at a distance of 1 ship length or ship breadth from the wharf, and then make a lateral move, berthing with the ship's heading kept parallel to the wharf. Wharfs and shore-based mooring facilities are usually designed assuming a berthing velocity of 15 centimeters per second. Actual berthing velocities are limited, however, and should not exceed 10 centimeters per second for ordinary-sized ships and 5 centimeters per second for large-sized ships. The function of mooring lines is to control a ship's motion and make the ship fast to a fixed position. Head lines and stern lines are used to control surge, sway, and yaw. Spring lines function to control drift. Moreover, since it's desirable that each line be extended as far as possible, it is necessary that attention be paid from above during berthing operations to ensure these maximum lengths. In cases of in-harbour ship handling accompanied by entering or leaving ports, ship handling without assistance is far from easy. In particular, the external force of wind and current has a great influence on keeping course and on changing course, on speed control, and on the directional control of ships. Taking the influence of external force into consideration, we are requested to implement berthing ship handling with the proper berthing approach angle and velocity, and to use assistance measures such as tugs and bow thrusters for ship handling.
Okay, let's step on to the bridges. You have your walkie-talkies?
No.
Did you leave the walkie-talkie on the bridge yesterday?
Yes, fully with that. Full on a bridge drive. Guys watching at home.